Hello and welcome to the YouTube channel of Canara Engineering College. In today's video session, we'll study regarding sensors and actuators which play a very dominant role in case of your embedded systems. So as you all know, when I build an embedded systems, the embedded system is built to be in contact with the external world. So whatever embedded system you are going to take, it has to be placed in the external world. So why do we have to place it in the external world? In order to accept the input and create action with respect to the input what has been accepted. So when I speak about the embedded system, so embedded system is always in constant contact with the real world, and the controlling monitoring functions executed by the embedded system is achieved in accordance to the changes that are happening in the real world. So whatever changes are happening in the environment where you have placed the embedded system is going to change the input and also the action done by the embedded systems. The changes in the system environment or variables are detected by the sensors and connected to the input port of the embedded system. So when you speak of an embedded system, your embedded system will be having input ports as well as output ports, isn't it? So it will be having something called as input ports and output ports. So at the input side of this embedded system, you will be having sensors, and at the output of this embedded system, you will be having actuators. You can call this actuators by the name transducers also. So these inputs which are obtained via the sensors are connected to the input ports of an embedded system, and the output devices or actuators or transducers are connected to the output ports of your embedded system. So let's check out what are the sensors made up of and what are the actuators made up of, because you already know what are this embedded system. Embedded system is nothing but it's a microcontroller or microprocessor which will be having a control algorithm as per your requirement or as per your application part, isn't it? So now it is time to know what are the sensors and what are the actuators. So basically a sensor is a transducer device which converts energy from one form to the another form which can be measured. For example, let me say that I need to measure the temperature. So temperature, how is it measured? I'll be keeping a thermometer. So thermometer will be measuring the temperature, and the measured temperature will be converted into a form which will be read by the user, which will be read by the person who is actually using that particular thermometer. So sensor is a transducer device. Transducer basically is a device which will be converting energy from one form to other form. So basically what the sensors will be doing is sensors will be connecting the energy from a form in which it is measured to either electrical voltage or electrical current. Why it is converted to electrical voltage or current is normally the voltage and current are two parameters which can be measured very easily. See here, sensor, an example is given here. Sensor which counts steps for pedometer functionality is an accelerometer sensor. So whatever number of steps you are going to keep will be counted by the pedometer, and the pedometer is going to count the number of steps, and it is displayed in the display that is provided in your smartwatch or maybe in the mobile phone application. Sensor used in the smartwatch application to measure the high intensity is an ambient light sensor. This is with respect to your automatic display. When you go to sunlight, the brightness of the mobile phone will increase. When you go to dark room, the brightness of the sunlight will decrease. That is because of the ambient light sensor which is placed on the mobile phone, which is going to measure the intensity of the light, and based on the intensity of the light, it is going to regulate the display of your mobile phone. So if an embedded system is designed for a controlling purpose, then the system will produce some changes in the controlling variable to bring the control variable to the desired value. For example, if I take a air conditioner, so let us say this is your air conditioner. So air conditioner will be having sensors here. So these are basically temperature sensors. They will be continuously sensing the temperature. Based on the temperature what has been sensed by the temperature thermometer, the inputs will be given to the control unit, and the control unit will be making the fan that is connected at the output side, which can be considered as a transducer, to work, isn't it? This is how it does. So basically, this is a complete embedded system which consists of a temperature sensor and a fan. Temperature sensor is your input device and fan is your output device. So sensor here is a thermometer and the transducer or an actuator here is a fan. So what it says is there are some embedded systems which will be sensing the variables of a environment where you have placed the embedded system, and it will do the controlling action as per the requirement. For example, let us say you have set a temperature of 23 degrees Celsius in your air conditioner. So the thermometer will be measuring the temperature and it will be 27 degrees Celsius. So it will give the input to the control unit that is present in the embedded system, and it will rotate the fan. The fan will keep on rotating until the temperature that is set by you people and the temperature of the room comes to a equal value. That is, when the temperature of the room equals 23 degrees Celsius, the temperature sensor will be giving the input to the control unit of the embedded system, and the embedded system will come to know that both the temperatures are equal, and it will make your air conditioner go idle. So there are embedded systems which will be doing the action based on the inputs that are given, and there are some embedded systems which will simply be measuring the input what it is given. For example, if you consider a ECG machine will be placing its notes on the patients and it will be continuously measuring the pulses of a human body, right? But it is not going to do any action. It is simply displaying the things. Whereas when I speak about an air conditioner, it is measuring the things as well as it is doing some action. So that is what it has said here. If the embedded system is designed for a controlling purpose, the system will produce some changes in the controlling variable to bring the control variable to the desired value. So controlling variable here is temperature, and the value what you are given is 23 degrees Celsius. So it will bring back the controlling variable to a value of 23 degrees Celsius and it will let it. And once the temperature becomes 24 degrees Celsius again your fan will be turned on and it will try to bring back the temperature to 23 degrees Celsius, and it will try to maintain the temperature at 23 degrees Celsius itself. That is your sensor. Actuator is, as I said you, is a device which is connected at the output side, which that also converts the energy from one form to other. So your control unit will be giving the signal in terms of energy, and that energy will be converted to a physical action by the fan here. So actuator is a form of transducer device which may be mechanical or electrical, which converts signals to corresponding physical action, and actuator acts as an output device. This is how it normally does the job. So that is what is your actuator, and that is what is your sensors are. Sensors are the input devices and actuators are the output devices. So when you speak about an embedded system, your embedded system will be having sensors or actuators, or it may be made up of only sensors. It is not necessary all the embedded system should be having the actuators. It is not necessary that all the embedded system should be performing a particular action. Some of them may be used only for measurement, and some of them may be used to measure a parameter and do the corresponding action as per the measured parameter. For example, if you take a digital thermometer will only be measuring the temperature. If you place that digital thermometer as a part of a sensor of an air conditioner, that will measure the temperature as well as it will give the signal to the control unit in order to perform the required task. There is an example that is given here. So temperature is being sensed here, and the input, that is the temperature, will be coming as an input to the control center. Control center will be sending the signal to the sprinkler. Sprinkler is nothing but which will be watering your gardens. So if the temperature of the soil is more than the set value, control unit will be sending the signal to the sprinkler in order to turn on, and the water will be sprayed on the soil. Suppose the temperature of the soil is equivalent to the temperature what you have set in the control unit, the control unit will be receiving the signal from the temperature sensors, whereas it will not send any signal to the control center in order to turn on the sprinkler. So this is what it basically happens. This is how it happens in case of your embedded system, or this is the function of your sensor and actuator in case of your embedded system. See, it's given here. If the embedded system is designed for a monitoring purpose only, then there is no need for including an actuator in the system. For example, an ECG machine. There is no actuator. It has got only a sensor which will be continuously sensing the pulses of a human body. So a broad difference between the sensors and actuators are given here. Sensor is an input device, actuator is an output device. Sensor converts physical parameter to an electrical output, actuator converts an electrical signal to a physical output. Sensors will be detecting the event or changes in the environment and sending the signal to the control unit or to an electronic device. Actuators will be receiving the signal from the control unit and performing the necessary mechanism. Sensors help to monitor the changes in the environment. Actuator helps to control the environment based on the input that is received from the sensor. So this is the broad difference that exists between a sensor and a actuator. Input output subsystem. Input output subsystem is nothing but it's a system which includes input and output together. So I can consider this as a subsystem where inputs are connected to an control unit and the control unit is connected to an output. So this can be called as an input output subsystem where your control unit will be giving the signal as per the input received from the sensors to the output transducers in order to perform the necessary action. So you can consider this to be an input output subsystem. Going with some of the examples for the sensors, you can, or some of the examples for the actuators. Light emitting diode or LED can be considered as one of the examples for your actuator. LED is an important output device for the visual indication in any embedded systems. LED is used as an indicator for various signals or situations. You are very well aware of that. Most of the devices will be having LED. For example, if you take your mobile phone itself, whenever you charge the mobile phone, there will be a small LED which will be blinking. Or if you take a power supply, as soon as you turn on the power supply, there will be a small LED blinking which says that the power supply has been turned on. Or as soon as you turn on a TV, there will be a small LED which will be turned on. If you turn on the receiver, there will be LED indicating that yeah, the system has been turned on. So LED can be considered to be one of the output device, but remember this output device is not going to perform any physical action. It is just used for a indication purpose. It is not going to do any action, just like how other actuators or transducers are doing. So LEDs, I don't think I need to go with explanation with respect to the working or manufacturing of this LEDs. So you know LEDs are very similar to your diodes. If I take my diode, you will be indicating your diode like this. If you take your LED, you will be indicating your LED like this with two arrow marks. This arrow marks indicates that it is emitting light. So basically, what is the difference between the manufacturing of your diode and LED? How do they differ in terms of the manufacturing? Basically, the manufacturing process is almost the same, but in case of your LED, the materials what are used to manufacture the LED is different from the one what has been used to manufacture the diode. What basically happens is LEDs are manufactured using a material which has got valence electrons. Valence electrons means the electrons in the outer band which has got high energy. There will be electrons in the outer band which has got high energy. This electrons will be, as soon as I turn on this particular LED, they will jump to the inner circle or inner orbit to combine with the protons, and the protons what are present inside will be having the lower energy. So electrons will be combining with the protons, but this electrons will be having the higher energy and protons will be having the lower energy. So in order to combine together, this electrons and the protons should be having the same energy level. So in order to combine this electrons before they jump to the lower orbit which contains protons, it will emit the extra energy out. This extra energy what has been emitted out is nothing but the light what has been emitted by your LED. The light what has been emitted out is nothing but the extra energy that is emitted by the electrons when the electrons are jumping from the higher orbit to the lower orbit. And the material what I'll be using in order to manufacture this particular LEDs are the special materials which has got valence or which has got excess valence electrons with the high energies. That is how the LEDs will be emitting light. When I speak about LEDs do have terminals which are called as anode and cathode. They have anode as well as cathode. Anode is connected to the positive terminal and cathode is connected to the negative terminal of the battery. and when it is connected to the positive and negative terminal of the battery, it is forward biased. When it is forward biased, the electrons will be jumping from higher energy band to the lower energy band, emitting the extra energy. And this anode, before I make the connection to the battery, I'll be connecting a current limiting resistor, because normally the current that is required for the LED to turn on is in terms of milliamps. So I'll be connecting a current emitting resistor in between the positive terminal of the battery and between the positive terminal of the LED in order to limit the current. And the value of the resistor depends on the current source or the battery what you have connected. That depends on the value of the current your battery is going to give. Normally LEDs can be connected to the output ports in order to show the indication. Whenever the LED is on, you can call it as logic high, and whenever the LED is off, you can call it as logic low. Other indication device or other indicating device which makes your job pretty simple, or let me say that, sir, I cannot understand what your LEDs are going to display, then in case of that, what you can do is you can connect a 7-segment display. 7-segment display is nothing but 7 LEDs connected together in terms of a in the form of 8 in order to indicate alphanumeric characters or digits. It can display anything. So this is what your 7-segment display is going to look like, which has got 7 LEDs which are being named as A, B, C, D, E, F and G, as it is shown in the diagram here. As it is shown here, it has been connected, and they will be having the pins in order to plug to the terminal where you can connect the 7-segment display, and the voltages or the current levels will be indicated by the 7-segment display. So basically, whatever LEDs you can see here are in turn made up of the same LED what I spoke previously. So this is regarding your 7-segment display, which you have studied in detail in your analog and digital electronics. So let me not get in detail with respect to the 7-segment display. But the thing what you need to remember here is your 7-segment display will be displaying the digits and alphanumeric characters, which will be easier for the end user to read it. Basically, you will be having the 7-segment displays coming in two configurations. One is called as common anode configuration and other one is called as common cathode configuration. Both of them, in fact, display the alphanumeric characters and digits, but one is called as common anode and other one is called as common cathode configuration. The circuit diagram for the common anode and common cathode configuration is shown here. In case of your common anode, all the anode terminals of the 7 LEDs are connected together. In case of your common cathode, all the 7 cathodes of the 7-segment LEDs are connected together. That is what is your common cathode and common anode connection. One more actuator what you have to learn, or what you have already studied in your last semester, is your optocoupler. So optocoupler is normally used to connect two different circuits which are electrically isolated. So let's check out here. You can say this is circuit 1 and this is circuit 2. There is no electrical connection between this. Whatever you can see here, this is a box here, okay? This is not electrical connection. Suppose you want to make your power pass from first circuit to the second circuit without any electrical connection, then you can go with the optocoupler. What are these optocouplers made up of? Optocouplers are made up of LEDs and phototransistors. Now what are these phototransistors? Phototransistors are basically the devices which turn on based on the light that is incident on that particular device. LEDs are the ones which are going to emit light, right? Phototransistors are the ones which are going to turn on based on the light that is falling on that particular device. That is what is phototransistors, or you can call it as photodiodes also. No issues. You can call it by any name. So if you connect your LEDs and photodiodes in this particular fashion, this particular circuit will be acting as an optocoupler. Sir, how does it transfer power from one terminal to the other terminal? See here, I'll be connecting this LED to a battery. As soon as I connect this LED to a battery, this LED will be emitting light. As soon as this LED emits light, the emitted light of the LED will be made to fall on the surface of the photodiode. As soon as the light falls on the photodiode, your photodiode turns on and it passes the current to the second part of the circuit. This is normally used in case of the circuit where normally there will be faults occurring. If there is fault that is happening in the secondary part of the circuit, and if you want your primary part to be safe enough, then you can connect a photocoupler. Optocoupler will be providing the necessary safety or necessary precautions in order to protect the various parts of the circuit. Normally, I'll be using this in the communication purpose. In the electrical connection purpose, I'll not be using this. I'll be using this optocouplers in the electrical, communication or in the signal processing purpose. This is a circuit which illustrates the circuit diagram of your optocoupler. You can see there is a optocoupler connected here and optocoupler connected here. So input from the sensors will be given to the LED and LEDs will turn on, and the lights from the LED will be made to be falling on the phototransistor, and the phototransistor will be giving the input to the embedded control unit. Embedded control unit will be generating the necessary signals which will be given to one more photo LED, and the LED will turn on, and the output from the LED will be given to the photodiode or phototransistor, and the phototransistor will be running the output device which is connected at the output side of this particular circuit. So this is how you normally use a optocoupler. Moving on, next, a very important actuator which is used in your embedded system, that is your stepper motor. So basically, let me tell you what is the stepper motor. Stepper motor is a motor which rotates in clockwise or anti-clockwise direction in terms of steps. For every step, it is going to cover around 16 degree. You can make your stepper motor rotate either by one step, or you can either make your stepper motor rotate by 8 degree. Which means that, as a simple example, not the exact one, if you look into the seconds hand of a clock, it is going to rotate in terms of steps. So that is how actually your stepper motor rotates. Your stepper motor will be rotating in terms of the steps. It can rotate in clockwise direction or anti-clockwise direction. So why stepper motor is a very important or very dominant component of embedded system. Normally, embedded systems are used in robotics. Robots means you need to be moving the arms or head or maybe the legs of a robot as per your requirement. So normally all this movement will be happening via the stepper motor itself, as per the input that is received from the sensors. So stepper motors are widely used in industrial embedded application, consumer electronics, very specifically robotic controls, paper feed mechanisms of the printers, fax machines, lot other applications. So let's check out how basically this is built. So stepper motor has got, or you can classify the stepper motors to two categories. One is called as unipolar and other one is bipolar. Unipolar stepper motor has got two windings per phase. So normally when I speak of a motor, your motor will be having two parts, okay? One is the part which is rotating and one is the part which is stationary. The stationary part is called as stator and the rotating part is called as rotor. Now, the stationary part is the one to which you are going to supply the energy. Based on the energy that is supplied to the stator, it will be producing a rotating magnetic field in the air gap between the stator and rotor. Based on the rotating magnetic field that is produced here, your rotor is going to rotate. In case of your unipolar stepper motor, the stator is made up of four windings. Two windings are named as A and C and the other two windings are named as B and D. Based on the direction in which the current is flowing in this particular stator windings, your rotor of the stepper motor is going to rotate. So your A will be carrying the current like this, and C will be carrying the current like this, B will be carrying the current like this, and D will be carrying the current like this. But remember, when the stepper motor is on, only one winding of each phase will be carrying the current. It is either A and B, A and D, C and B, C and D, or something like that. Not all the four windings will be carrying the current in case of your stepper motor. So if A is carrying the current and if D is carrying the current, then the current in this is in this direction and it will be producing the force in the clockwise direction, and D it is in this direction and it will be producing like this. Once the rotor comes to this direction, then B will be carrying the current and C will be carrying the current and it will be continuously rotating the rotor in the clockwise direction. Sir, what do I do if I have to rotate the rotor in the anti-clockwise direction? You just reverse the direction of current in the windings A, B, C and D. That is what is your unipolar stepper motor working. Coming to the bipolar stepper motor has got only two windings. That is, it is made up of like this. It has got one winding here and it has got one winding here. Maybe A and B. It will be carrying current like this and it will be carrying current like this. So that is what is your bipolar. It contains only one windings per phase. Whereas unipolar will be containing two windings per phase. No matter it is unipolar or no matter it is bipolar, only one winding of each phase will be active at a time, or only one winding will be carrying current at a time. See here, the various ways in which you can rotate the motor has been given here. For example, if you want to rotate the motor in the full step, if you want to rotate the motor in clockwise direction by 16 degree, you need to energize your coil A, you need to energize your coil B, C and D has to be turned off. If you have to rotate further, you have to bring this back here. So B and C will be energized and A and D will be off. If you have to rotate it further, A and B are off, C and D are on. If you have to rotate it further, A and D are on, B and C are off. So this is how it continuously rotates in terms of steps. It continuously rotates in terms of steps. Suppose if you have to rotate in terms of waves, waves in the sense one step and again rest and again one step, again rest, again one step and again rest. Then the coils has to be energized in this particular fashion. Only one coil has to be active at a time. A, B, C and D. That is how it has to be energized. Suppose if you have to rotate in the half step, then you have to combine full step and wave step together and you have to write. See, first will be this one. First will be here. Second one will be this one. Third one will be here. Fourth one is this one. Again, the fifth is this one. Sixth is this one. Again, this is here. Again, this is here. In this way, you can rotate in terms of half step also. So this is how you can make your stepper motor rotate based on the requirement. We are not going in detail with respect to the stepper motor. As a matter of knowledge, you need to know that stepper motor plays a very dominant role in case of as an actuator in your embedded system. And your embedded systems stepper motor is of two kinds, unipolar and bipolar. The difference between the unipolar and bipolar. The connections are shown here. This is the winding. So internally you can see this is your rotor. This is how it is energized. So when this becomes north, this is your coil A, right? So this is A, C, B and D. So this is north, this is south. So when you make this A positive, this becomes north, and B is, this becomes south. So south will be attracted here, north will be attracted here. Again this north comes here, this will become south, this will become north. So this is how it will be continuously rotating. You can rotate your stepper motor as per your requirement. It is not necessary that you have to rotate it by half step or full step. You can rotate it as per your choice. Thank you.